continuation of our lab. So today we will be continuing with the second part of the second lab, which is to deploy a service with the Azure ML Designer. So remember in our last session, we created the pipeline that we also evaluated, and we scored and evaluated. So this time we want to use the inference compute to test it, to convert it to an endpoint that users can send or call in an application and send values to them, and it does prediction and gives back the result. So that's all we are going to do today in this first lab. Okay, so the prerequisite for this lab is that you ought to have completed lab 1A and lab 1B, and also you should have completed lab 2A and before you get here. So lab 2A was where we did all the designing and then the scoring and the evaluation. So in this lab is to convert to the inputs, add an input module and also add an output module. That's what we need to do now. Okay, so we're going back to our Azure Machine Learning Studio, and then we are going to create another compute. So these are the various computes you have there: the compute instances, the compute clusters, the inference clusters, the attached compute. So this one were the ones we created in the previous lab. We created also the compute cluster, and I said this is for your test environment. And then if you are going into production where someone can call it, this is where we are going today. We're going to be working on the inference cluster today. And you can see we've not created any of that yet. Let's go to our compute. So remember we stopped the compute instance. The compute instance we created, and then the compute cluster is still up, but we need to change something. Change the number of nodes back to 2, minimum number of nodes back to 2. Okay, so while that is going on, we'll have to go back again and turn on or start this guy again. So let's start it. So while it is starting, we continue on to the next. So if your compute instance is not started, you would have to start it. And then we are going to add a new cluster on the inference clusters. So these are the specifications for the cluster. We're giving it a Skills Lab inference cluster. Then the Kubernetes service, we would have to create a new Kubernetes service, then add a region. Who can remind us which region we've been using ever since? Yeah?
Central US.
Is that?
Central US.
Central US. Of course, you can always come here and check. This is our location we've been using, and then always try to put your resources in the same region, and then the next thing you would have to do, just for availability sake and fault tolerance and the likes, you need to also do the backup, a backup at another region, just in case this region goes down, the other region should be working. You can do that maybe according to zones. So different availability zones that you can implement to keep your services up and running at different points in time. Right, so let's go to the Machine Learning Studio. So we come to inference clusters. So now we're going to create a new one. So the location is Central US. Then, so the specifications we are to make here is standard DS2v2. So standard DS2v2. So this is it. Next, we give it a compute. It's a skills lab inference. Okay, so the cluster purpose, we're going to use the dev test, number of nodes, 2, and network configuration basic. We are going to unselect and SSL configuration. So 2, oh, this is 12. So okay, so selecting dev test for production, it is requiring you to do 12 nodes. So if you're going to production, it requests you use 12 nodes, but since we are doing a development test, we are using just 2 nodes and then, okay, so I think we look fine. So let's create. So while it is creating, we can move on to other things. So let's check if it is in a creating mode. Okay, so it's creating. So the next thing we are to do is to go back to our inference pipeline and then make some changes to it. So we are going to set the inference pipeline from the design page. So we come back here, to the designer and select the pipeline. This was the pipeline we created previously. Then you come up here and click on Create Inference Pipeline. So this time we are going to use real time. So your application can actually call this at any point in time, send data to it on the fly, on the go, and it will process and give back results. So this is what you typically need in a software, in a user, and in an end user software application. So any questions so far, guys?
None.
Okay. So it's going to create a new version for that pipeline. So we are going to name it to predict diabetes. To change that name to this. Good. So you save the work, or you can do save, whichever one you like. So we are going to make some changes to this. We don't need this evaluation, so we would have to remove it. And then other ones we don't need. We'll be removing them one after the other. Okay. So remember that your data is already in an encapsulated state, and because of the transformations we've applied. So every other new data that is going to come would have to pass through the normalization module so that it will undergo the same thing. Remember, we set different things here. The transformation did that about the data set, and this is the input. So this is the name, web service input, and then whichever data you send to this endpoint we are creating is actually going to come in through this. Okay. Right. So we are going to remove that aspect of it. Okay. So the inference pipeline now, we always assume that your incoming data matches the schema of the data we used for training, and then because the data set of the one we used for the training is included by default when we created the inference pipeline. So then the next thing we will need to do is that we will need to delete the model, and then we'll replace it with the enter data module. Okay, so there, because from this, we would be able to, like I said, add new entries or new data to it for prediction, and also be able to use it real time in any application. Okay, so what we do at the end is going to look like this finally. So we are removing the data set and then replacing it with enter data manually. Okay. So this is going to be removed. I'm going to shift this here. So we are going to input output here and bring this enter data manually. This, so it's CSV, has headers, and then we are going to put the data. Sorry. This is the data we are going to enter. So look at this. The data here does not have the label. We have patient ID, pregnancies, plasma glucose, and all the other one. But the label, and if you recall, our label is the diabetic colon, but it is not here. So we've removed it so that it's going to predict, because these are actually new data and we don't know. We want to predict if this person has diabetes. So we can't have it here because we don't know if they have it. So the algorithm is going to predict if they have it. Okay. All right. So so we are going to copy this data, paste it here. Right, so that's that. So we are going to connect it to this transformation. So it's going to transform and do a normalization. Remember, under our transformation model, what we selected was the normalization. So it's going to normalize the data we imputed from here, then run it through everything. So this evaluation model, we don't need it, so we are going to delete it. So everything looks like this. Let's try to arrange it well. Okay. Yep, and right. So everything looks exactly like this. So at a point in time, we are going to add a Python script to it, then make our whatever changes we are going to make. Okay, so now the output of the model will of the score model will include all input features, including what we predicted and the prediction score. So just to be able to limit the output to exactly what we want, we are going to use Python language and make some changes to it so that we only have exactly what we need. So this is going to bring out the score results in this format that we specify here to set the label to diabetes prediction. And then, of course, this prediction is going to be in the other format that we said, that is 0 or 1, then the probability itself. So next thing we need to do is to add the Python script to the score model, and then we connect it to the leftmost, the dataset one. So in this format, like this, connecting to the execute data Python script. So let's search. Sorry, close this. Remember, I've shown us before Python language and all that. So we have for Python and for R. There's no scalar here. We also have for web services, web service input, which was we have here. Okay. So we're going to do.
Sorry, sir. I think there's a question from Joshua and Aziz.
Okay. Joshua?
Okay, so now, can you hear me now?
Yeah,
Can you hear me?
hear you. Yeah, I can hear you.
Okay, sir. Okay, sir. I'm so sorry for coming late. I'm so sorry. I just came online now, so I saw the data set you took from the, what's it called? You took the data set, you actually pasted it there, and you said the label wasn't among, which is what you are looking for. On the normal traditional method, I don't know. It's not all the features we use to predict, like the way that means the one I was using there will make use of its map to know the one that correlates. They will use the one that correlates to run the algorithm. So I don't know why is it that you copied everything. Yeah.
Sorry, I didn't get you.
Okay, now the data set you took, you copied from that other page.
Which is
I think
this?
you copied. Where is it? Yes, this data set, yes. Now, and you said the label is not here. Now, the normal traditional method when we make use of a Python, when we visualize, we run the exploratory data analysis, then we make use of its map to know the one that correlates with the label. Then we will not choose those features to run the algorithm.
When you are testing?
Yes, we want to test, yes. But yeah, it's as if you copied everything. I don't know if it's two different things.
Yeah, it's everything. It's everything.
Okay.
I understand the one you are saying. That you just
Okay.
look at what correlates to
Yes.
the label itself using
Yes.
your heat map
It's
or
math.
other means of
Yes.
checking the correlation, and then you just use those features that are correlated to the label, and then
Yes.
so in this case everything here is correlated.
Okay.
Okay.
Is there any way we can check for it here?
No, you can't.
All right. All
Yeah.
right. All right.
So thank you for the question. So basically,
That's my own question.
okay, one more question.
Yes. So my own question is it because we want to enter our data sets manually? Is that the reason why we introduce our inference pipeline? Because I noticed that when you pick our runtime, which is the real-time inference pipeline, I noticed that our model change. You
Yeah.
understand? Then some models that we have before, like the train model, then the normalized data, were not there again. So now we have some other model. So what I want to clarify now is it because we want to enter our data sets manually? That was why we introduced our inference pipeline.
Okay, so not because we want to test it manually. Now, let me say not only because, okay? Not only because of that. Right. We can test it dynamically using a web service input. Okay. And you can also test it manually by putting test data here.
Okay.
So the reason we created the pipeline, the inference pipeline, inference means you want to deduce something from what exists, right? So
Okay.
we've created the model, we've trained it, and it's working. Now what we are trying to do is to test it with data, and you cannot test it on the training pipeline. So remember, we have the training pipeline and we have the inference pipeline.
Okay.
Okay, so these pipelines are two different things. You can't test from here except through your split data. You can only test through your split data. But here, you can add new data to test the model you created from here.
Okay.
I hope this is clearer.
I understand.
Okay. Okay, so we've added the execute Python script and we are going to replace all this here with this code. Yeah. Okay. I hope we are following so far. Didn't copy anything, right? So sometimes these editors can just be an issue with Python. Especially with the indenting and the likes. Enter data frame. Okay, so the reason I'm writing this is just to be sure this guy did not, to be sure it actually did the right indentation. What's it called now? Python. What's data from 1? Then we do patience. Just copy this. Yeah. Okay. Results. Name. Columns. Let's equal to this. Okay. So I think we are almost done. So let us return score result. Okay. So I'm going to delete this ones. Wait. Saved. So I think we are good. Everything looks fine. So now we are going to publish it, and then we'll be able to test what we've done so far. So we've been done with task 1 and task 2. Now up to the task 3. Now I always say you have to submit first, and then you'll be able to publish. So let's go submit. We would have to create a new one. They asked us to select a new pipeline. Yeah, so a new experiment, and we are going to name it Predict Diabetes. And predict diabetes. So okay, so we're creating a new experiment. And then once that is done, we are going to now go back to the compute inference and see once that experiment has been created, Remember, we're creating the inference we initially when we came here. So, okay, good. It's been created. It was creating before we moved to the design interface, and we did all the changes we just made now. So we are back here, and under this is what we just created. So now it is ready for use. Okay. Whew. All right, so we are going back to that design tab, and then we are going to go back to the inference pipeline and then see if it has finished running or we submitted for it to run, and also check if there are errors in the changes we've made, and then we are going to view the result set from this model. Okay, so we are going to see the predicted labels and the probabilities of the 3 patients we just entered manually. So back here. So these are the, it's still running. Okay, so it's not done yet, still running. And while that is on, let me take questions from us. Any question, guys? Questions?
No, sir.
Okay.
No question, sir.
Is it clear so far?
Yes, sir. Yes, sir.
Just in case you are not clear on it, you can always call me back, or you can also follow up on this. You can also follow up on the tutorial when I publish it on YouTube. Okay. So we're waiting for this guy to finish running. Let's refresh. Let's see, still running. So I would recommend that you explore the different things. So it's still running, still has all this to start and run. And before we check our output here. So, and just heads up, the next one, we are going to test the web service. Then we are going to generate endpoint and the key that anyone can use. And then we are going to maybe test it from the Jupyter node, and then we'll consume using the endpoint and the primary key and see how it would work in a normal application, a normal software application. Okay, so then once we are done, we will then delete the web service because this actually costs money. Then we'll stop the compute before we move on to our next lab, which is lab 3. Okay. I just hope it's been interesting for you guys so far. And if not, you can also, I'll say, leave a comment in the chat session, and then I can follow up from there. Okay. All right, so we are here. So we're almost done with the run. Just taking time. So is anyone ready for the exam?
Not me.
Not yourself.
Said not you.
I don't know if other people are ready, but I know I'm not.
Okay. Olamide, I think you specified AI 100, right?
Yes, sir.
Okay.
But I still have to write this one too.
You said?
I said I will still be writing this one too.
You only have one voucher.
Yes, AI 100. But I have another one through one of the programs that we were supposed to attend through SIDMAC.
Which of them is that?
Ignite.
Oh, okay. Ignite. They gave you voucher.
Yes.
Okay. Lucky. You guys are lucky there. So you have 2 exams, 2 more exams.
Yes.
Yeah, so in this time around, I hope you guys remember you only have one chance at the exam. You have only one chance. And so it simply means you need to do better. Like you need to prepare. I would not recommend you rush. I would only say just prepare well.
Yes.
Okay. So this guy we are just waiting for. Oh, it failed. What's the error?
Okay, sir. Okay, sir. I want to ask a question. It's
Yeah.
not really pertaining to this stuff, sir. But I want to ask now. After the internship, now what next? If I may ask, or if I may know.
Well, I think employment is next.
Okay.
Yeah, so employment is actually based on your performance and the whole um, learning or the whole internship program.
Oh, I see.
Yeah.
Okay, sir. All right, sir.
Yeah.
Thank you.
Wondering why this guy said there's an error now. Let's run again. This time it should run faster and come here. So I'm wondering why true error. Hopefully this runs well this time.
So is there no way to pause the recording and then play it?
No.
Wow. So I have to.
Except to stop it.
Oh. Because we have to wait.
Yeah. Had it been its Camtasia Studio screen recorder now, you can pause. It's trying to finalize it. It's failed. This is. So I'm wondering why this guy is failing at this point. So let me do something. Just copy exactly as it is here and see if that works. I'm only going to run the module that has changes, which is this. So let's hope this runs now. Let me do a check. Aha, it's run. So what was the mistake there now? Let's see, results, data. So it ran well. Wow. It predicts that they all have diabetes. This is okay. So when you can imagine you actually tested for three new patients with these patient IDs with all the data, and it gives you this result. Will you trust this model at this point?
No.
No.
It's like
at all. There
Why?
should
it's like
be
it seems like
disparities.
everybody that was getting tested for corona had the corona. People start running from testing.
Okay, it's like I only got your last word. I didn't actually get what both of you
I
said.
said, oh, I was saying that if it seems like a center, for a center, everybody that is going is getting positive results. People will stop going to the center to get tested.
Is that why you won't trust it?
To some extent, yes.
So I think what
So-
this means is that you won't trust it because like there should be differences in, like it shouldn't all just be positive. There should be what's it called? A variance in how the result, at least maybe one person might be negative, or if you test for 10 and then it's all positive, you
Yes.
test for 20 is all positive, then that means the model isn't working well.
Well, you're not certain, remember? What if the result is actually a true positive, like true positive? All of them true positives. And what
Wow.
if the one you are hoping to see that one of them should not have? And what if that is actually a false negative?
Okay, I didn't think of that.
So, so that's why I asked you if you guys can trust this model at this point. Can trust the model at this point.
But according to the model, we can't see any precision or accuracy results yet.
Look at what it's saying now. Over 85%, 70%. So I can say you can doubt this, but then there are other times when a machine could just score something very high and it's actually a false positive. But anyways, the machine is just telling you there's a possibility. Okay, that there's a possibility that this person is actually diabetic.
Yeah. So this is
Okay,
something I was asking in our first session.
you said? What did you say?
Yeah, I said I was asking you in our first session that because since it is a logistic regression classifier, that to probably give us answers in 0 point something. So
Yeah,
like according to the result, it seems to be giving us answers, but it's also classifying.
yeah. So remember, we're using a two-class logistic regression. And what it tries to do is, based on the two classes, it tries to round up to any of the classes.
Okay.
Do
But
you
sorry,
understand?
I want to ask another question.
Okay.
Was there any point where we defined the boundary probabilities that okay, 60% and below for 0 and greater than
It's
60
actually in the
for 1?
algorithm. It's actually in the algorithm.
In their own algorithm, is not defined by us.
Yeah, not defined by us. It's actually in the algorithm. The two class logistic classification we did.
Okay.
Yep. Okay. So let's move on so that we can finish this lab aspect. So the next thing we are expected to do is to deploy the model. So what we are going to do is to click on deploy, and then So there are other materials here for you to check. That's how a documentation page for the designer, machine learning studio designer, can come here. All the information you need, you can get them here. It's for the documentation. I think I usually prefer the documentations than watching tutorials. Except it's a very unique case that is not answered here. So you can bring your own whatever to this, or your Python script, Jupyter notes, working on the studio, the CLI, Visual Studio Code, and all here. Different machine learning frameworks, TensorFlow we produce here. So this is helpful. I've shared this with you in the chat session. Okay. I think there's a sample GIF image here that can show you all you need to do. So the next thing we are going to do is to click on deploy. And we are going to give it a name. Did I copy the name? Let me see. Predicted diabetes. Let's give it that. So this is the Kubernetes service. Then compute cluster, the inference name are the ones that we've selected. So we are basically setting all this, or if, in case we want to replace this, we are not actually doing a replace. So this is the name. I think I got the name, yeah. Yep. So once we are done, that would be all. Then we'll wait for it to run. So let's deploy. Let me check this advanced settings. No. We don't want application insights. So let's deploy the model. So this is the point where you are converting it to something like a URL that someone can send test data to, and it will pass it through the algorithm and give back an output or a result. So this is what the deployment is about. Are we okay, guys? Right,
Yes, sir.
All right, so the next thing now, we are going to work on the test. So on this endpoint we are creating now, which is this real-time endpoint, we are going to consume it with the REST endpoint it's going to create, and also a primary key. Don't worry, we'll see the primary key once it is done. So we are going to open another browser tab, and then from the compute, just like we did in our previous lessons and all that. So we go to this file, designer here. So it's still deploying. So while that is happening, we can go back to the compute here. So Jupyter to open in this one. But the endpoint is not ready. I'm just taking us so that we'll not waste time. So you have to go to the compute, come back to compute, and then under compute instances, click on Jupyter. Then it will open this lab for you. Then you go to DP-100. Remember, we created this in our first lab. I know. So we're looking for this using the visual designer. This is what we need. And once the endpoint is ready, we're going to use it to test. So we are going to get the endpoint and then the primary key once it is available. But for the meantime, it is still running, so we can't actually run what we do a run and what we need yet. So maybe from your Python code, you can do a test. So just in case you are very familiar with Python, you've created a model on Azure Machine Learning Studio, and you want to test, this is how you can test. Just have your endpoint and your key, your primary key, and then write your Python code, specifying the data set as global parameters, and then set your body, encode it, and then set your headers application/JSON as your content type. Then you set your key to your bearer for authorization, and then you come, you set up your request URL or your request, what do you call it now? Or let me call it a requester. Set up your requester, then to be able to check or manage your errors, you use your try catch. And so in case you are used to try catch in other languages, this is a Python implementation of a try catch. So you set up your request to the requester you've set up here or you've created here, and then you get your response, your result from this, and then also set it to JSON. Then you check your output. So this is where how you locate your results under results, web service output at index 0. Then you put out your print or your printout, which is going to show once we run here. It's going to output this 3 colon, the patient ID, the diabetes prediction, and the probability. So this is how you test, just in case you are used to Python. If you're used to C# or JavaScript, you can also do that. Just so far, you can do an equivalent of this code in your own implementation. Okay. So let's go back and check if our endpoint, yep, I think it is done. Sorry. Yeah, so our deployment is succeeded. So let's go back to designer. Okay, these are the ones that failed before. Okay. Sorry. Yeah, the deploy details. So let's see. This is the model ID. This is the endpoint, and then hope I've not passed the key. So it also shows you how you can do a test. If you click on test, it will do a prediction for you. You can change the values here, then see what it gives you. Okay. So you can do a test here. It will show you in different languages how to consume. So this is the C# equivalent. Remember, it looks almost exactly like what you saw in the previous page.
But this look like SQL.
What? It looks like
This SQL.
C#.
SQL.
No. I'm not sure C# looks like it. This is C#. This is C#. This is the Python equivalent, the one you saw just now. And this is the R equivalent.
So any of this code that can run.
Yeah.
Okay.
So this is our primary key. Let's copy it and paste it here. Then we copy the URL, which is this, and paste it here. So I guess we are good. So let's see if this runs well. Yep, and it does. So it gave us this prediction that this person is diabetic.
Again.
She said again.
Everything has been positive.
Yeah, well, that's what your model says. That's what your model says.
Yeah.
So it does a login of everything that you're doing. I think that brings us to the end of testing. So like I said, whoever wants to consume this model in any software application, all you need to give them is this endpoint, the endpoint, and the key. That's all. So you give them the endpoint and the key, and you tell them the schema to send. So this is the schema to send.
So when they have the endpoints and the key and the schema, they will arrive at that endpoint.
Yeah. No, so then if a software developer already knows what to do, okay.
Okay.
So you tell them that this is actually a post request, because usually a post request would require you to send a body. Don't worry, a software developer already knows this language, especially for a front-end developer. You already know what a post request is, a get request, and the likes. So this is actually a body. So this data is going to be part of the body. So you set it up as a JSON format, or a JSON, JSON format data, and attach it to the body in an encoded state, and then add it to your request. So your request already should have an endpoint, the body, and the header. So you've set up the header here this way, then you set up the body, and you already have the endpoint coming from here. So the remaining is just for you to send the request, get the response. If there's an error, maybe the service is not up again, you catch the error and also log it. Okay, or you print the error or you log the error, whichever one, depending on the environment you're working in or your company, if they like to log errors, depends. That depends. Okay. So I think now that we are done, we could. So we've seen the output. Now we can delete the web service and move on to the next lab. I hope that we have enough time to finish the next lab. Okay. So I'm going back to our endpoint. So I'm going to delete this endpoint because this endpoint is going to continuously run, and it is using Azure Kubernetes service already. So I don't know how much it has eaten out of my subscription, but I have to delete it now. But we've seen how it works, and then we know how to consume it. And that will be all. So I'm deleting it now. Any questions so far? Yeah, we wanted to use this guy. Tino has nothing. Any question, guys?
I have a question.
Okay.
So when will the video be available?
It may be available tonight or maybe not tonight. It depends.
So this night or tomorrow morning?
Yeah.
Okay, sir. Thank you.
Okay. Thank you.